Welcome to week 6. This week we're talking about files, writing to files, reading from files, all kinds of fun stuff. We're going to just jump right into it. This is not an exceptionally long chapter, but it is a little difficult sometimes in understanding some of the concepts involved, and there's a new format and notation that we're going to have this week with what we're doing. So here's what we're talking about. We're talking about file input and output, the three different modes for working with files: reading, writing, or appending. Using loops to process files. So yes, we're going to blow the dust off of whiles and for loops and bring them back in a little more practical sense as far as reading data. We're going to talk about processing records in a very, not in a vague sense, I guess, but in a very loose sense. Maybe that's the better way of phrasing it. Certainly text records. And then we're going to talk about exceptions, which are very important when you talk about file handling, but they're not exclusive to file handling. I know a few of you have tried it with labs already, and it's worked out to great effect. It's just some error handling along the way, and we'll get there. First, some terminology, though. Every time you run a program, as you know, you've got to re-enter everything again. You've got to run things again, type things again, in order, obviously, to make sure that you retain that data in between various runs. You need to save the data somewhere a little less volatile than memory. And as we know from the first few weeks of the course, that involves a disk. When you write data to a disk, you're saving data on some kind of file name, in some sort of file on some sort of disk. And the file that you write to is called an output file. It's very simple. Disks are actually round. If you've ever seen one before, I know everybody associates the square floppy disks, but they're actually round on the inside. So are your hard drives essentially as well. But when we do this, we're basically taking everything that's running in memory and being processed in memory while the program is running, and then writing this out to a sequential file generally on a disk. So and if you're writing out a record is a various set of various things: name, employee ID, and maybe a pay rate, for example, and that would be a file sitting on your disk somewhere. When we're reading data, we say we're reading data from, which is basically getting stuff from the disk, from the file on the disk, and bringing it into memory to work with in the program. And the thing we read in is called an input file. So we write to an output file, and we read in from an input file. Yes, they are the same thing if you're using a program to do both. But that's how you refer to it, is the input file and the output file, so we can do our processing. There are 3 steps when we go to actually process information to or from a disk. We have to do what's called opening the file, and that involves setting up a variable with a file name, and Python creates something called a file handle we'll say about. And then we actually do something with that file to process it, and then we have to close the file when we're all done. And that actually keeps our disks in good working order after the fact. So again, it looks something like this. We might have a pay rate and an employee ID and an employee name, and we basically copy it right from RAM into that file. In general, we have 2 different types of files that we will talk about. Basically a text file or a binary file. That's pretty much the general gist of it along a computer. We know binary data is any data that is in ones and zeros. A binary file is the same way. It's data that has not been converted to ASCII kind of text, where a text file is something that we can actually read. Again, usually in ASCII, could be in Unicode. And what we're going to work with are text files at this point. Again, we've talked about, I mentioned this before, sequential or direct access. We're going to work, at least as far as this chapter is concerned, with sequential access, and that is basically writing pieces of data from start to finish without kind of skipping ahead or anything. We're just going to write it from beginning to end and work it that way. Direct access means you can jump to literally any point inside a file and write just certain elements of it. So we'll get there. A lot of terminology, a lot of terminology. Every computer has file names and file extensions. A file name extension is basically a few letters after the file name, usually after a dot, that indicates the type of file that it is. For example, all of our Python files, we know, have to end in .py. Py is the file extension. So we might have a file called lab5 part 4 .py. Lab 5 part 4 is the file name, and the py part is the file extension, the dot separating the name from the extension. And then we'll talk about a file object. And the object is basically, it's just that, it's an object. It's this abstract term of a container, if you will, that contains the data for the file that sits on the disk. And essentially that whole thing, Cindy's name, her ID number, and her pay rate, all of that, the big giant box around it, that is the file object. So, how do we open a file? What does that exactly mean and look like? You use something called the open function. It basically creates what's called an object, a file object, and then it basically associates that with a spot on the disk, whether that is a real file that already exists or one you're going to write out. There's also a mode involved, and there's 3 modes. Reading, just reading from the file and taking input. Writing to a file, or appending, which is a special version of write. That special version of write basically, instead of overwriting the whole file from beginning to end, just adds on to the end of it. It appends on to the end of it. So again, the format for that, in the color-coded text there. Some variable name that stands for your file object. Equals open, whatever the file name is, and because that's a string, it will go in quotes, and then comma, the mode. And the mode is just 3 little letters, R for read, W for write, or A for append. The location of the file is kind of important. Wherever you installed Python 2, that is generally speaking where your what we call the working directory is. If you think about how your computer is set up to save files, when you go to hit save, generally speaking, you're probably in the My Documents folder if you have a PC. Actually, I think the Documents folder now is just called Documents, and it's the same on both Mac and PC. And you can change folders, that kind of stuff. But whatever folder you're currently in, or at least that you launched the program from, that is where Python will look to open the file. So if the file that you're trying to write to is in the same place as your Python program, then you're in good shape. If not, you're going to have to give a whole long path that involves, if you're a Windows user, it's going to involve // documents / whatever. If it's Mac, it's going to start with a slash. But if your program that you're running is not in the same folder, the same directory as the file you're trying to use, then you will have a problem if you don't give it the full path. We're going to work right now, for today's lecture at least, on files that are in the same directory. So what I've done actually is I have made a folder, and in this folder I have all my Python files that we're going to use, and I also have all the text files that we're going to use. So again, it makes it easier, at least for the purposes of what we're doing right now, and probably for your labs as well, if you work in the same directory, same folder. When you write data to a file, basically you use what's called the write method. So what is a method? This is a new terminology for us as well. It's basically a special function that only belongs to an object. What does that mean? Think about when we started writing functions. When we said we had functions, we talked about scope of variables. And if you defined a variable within a function, that variable only stayed within that function and nowhere else. Think of a method as a function for a particular variable that we have, kind of in the opposite approach. We have what we call a file handle or a file object. That object, whatever we decide to call it, it looks like a variable as far as you're going to tell in code. Okay, we might say file handle equals open whatever the file name is and whatever method that we're using, probably W for write in this case. File handle being our object, the variable that we're using for our file object. And what we do is we have these special, for the file object, there are special functions that only it can use. And the same way we used libraries is the same style of dot notation that we'll use for these special functions, these methods. So what you'll have is again, if we called our file handle, if we called our file object file handle, we will have file handle dot write and file handle dot close. To write data to a file, to read data from a file, there's a similar read method, and to close the file altogether when we're all done. You'll see this in code very shortly. In fact, let's look at one right now. Why not? This is a very simple file. Okay, very simple program that will write 3 lines to a file. We did a long function here called main, and we're just going to call the main function. Inside of main, we have our file handle called output. Output is equal to open this file name here, philosophers.txt, it's in quotes, and then this W, it's a lowercase w, inside quotes as well. And what this says is create a file handle, a file object called outFile, and use that to open this file name from our disk. Then we're going to use, instead of using print like we would to print something out to the screen, we're going to use something called write. And write, again, is a special method, a special function that only belongs to our outFile variable here that we defined with our open statement. So we're going to use this dot notation and say outFile.write, and then just like a print statement, we can put whatever we want here. So we have 3 philosophers' names, John Locke, David Hume, and Edmund Burke. If you know who they are, bonus points for you. And we're going to put a new line character when we're all done there, okay? Because we want to have them in separate lines in the file. And that's about the only difference. You have to specifically mention or at least print out the new line character here. So we have our 3 things, and again, very similar to print, only instead of going to the screen like print does, outFile.write will put this into our file called philosophers.txt. Then when we're all done, we call the close function. And again, these are functions, so there's parentheses around everything here. And we say outFile.close. And that closes the file off and actually does something very special at the operating system level to put an end of file character that you don't have to really worry about, but it does special things to make sure your disk is, and your file stays safe. And if you think about actually, if you've ever ejected a USB disk or a thumb drive from your computer, and you have to go to that little special menu and say, eject this disk, and it waits a few seconds. Sometimes it's really long, and sometimes it's kind of short. And then it says, hey, your drive is now safe to pull out. That's what it's doing. It's making sure all the files are closed. It's part of something Windows does. When you write files to a USB disk, it doesn't always close the file immediately. It sometimes waits till later to kind of save your computer from being too busy. And that's why it's important to do that with your disk. It's doing this close function on all the files that are open in the operating system. So, real quick, let's just look. We have our text files here. As you can see, I do not have a file called philosophers.txt. Okay? Now we're going to come over here. I'm just going to hit F5 to run this. And this didn't come up on the right window, but you get the idea. It basically ran it. How do I know it ran it? Well, I didn't get any errors. That's a good sign. And if you look, now I have this file called philosophers.txt, which has our 3 names inside it. Lots of windows open at this point in time. So, we have our, way too many windows open. We have our, again, our procedure. Open a file handle with this file name and this file extension. We are going to write this file, and to that file we're going to write these 3 lines and close it. One more time, since all the windows are on this screen now, I'm going to close this window, I'm going to delete this file. And we are going to, one more time, run all this. If I can have these all here at the same time, you will watch as when this runs, we're going to see the file pop up right in here. Ready? We're going to execute. It runs, it says restart, and look, our file popped in there. And there it is. There's our file. Very simple example of what you'd do to write a file. Okay? And for that matter, I can do this all day long with anything else. I can call this cpt101. Let's see, let's just keep the characters out of there. cpt101.text. We're going to say my name. We're going to say week 6. And we're covering files and exceptions. Plain and simple. We're just going to write these things to a file. And if I save this and then execute it, it runs. And down here, we should have a new file. Here it is, cpt101.text. And what I told it to write, it writes to the file. Very simple. Some new concepts involved, for sure. But that's all it is. Bring those back to where they were, in case we want to use that later. Undo is your friend. Alrighty, so that's writing data to a file. Now how about we read from the file? Just like the file handle .write method, we have a file handle .read method. We also have a method, and that works, it reads an entire line all at a time. Reads the entire contents of a file into memory. Read line reads a line by line from the file. And then we have something called a read position. That read position is a variable that marks the location of the next item to be read. So if we read one line and we do some processing, we go back and that read position tells us where to start back from again so we can read the next line. Okay? And let's look at this again. So here we go again. We have the philosopher's text file here, right? Can I make that font a little bigger? Just so we can all see what we're talking about here. And now we're going to look at, not that one, file read. And as you can see, this is going to look a lot like file write. So on the left here, I have file write. On the right here, I have file read. Again, we have a function, we have a main function. That shouldn't surprise you at this point, the main function. And now I'm just going to call it infile in this case because we use descriptive variable names, right? And what we're going to do is we're going to open philosophers.txt, this same file, only this time we're opening it for read, not for write. So we have a lowercase r in there. Then we're going to read the entire contents of the file, all 3 of these lines, using infile.read. When we're all done, we're going to use infile.close to close that file and be good little stewards of the file system. Then we can print the entire file. Okay? Now remember, when we wrote this, we wrote new lines into this file. Okay? So when we print it, we should see essentially the same thing on the screen. Would you agree? I hope you would. Now, let's bring up our Python shell so we can watch it execute as we do this. And I'm going to hit execute. And there you are. Here's our starting program. Oh, look at that. It printed off 3 lines and then a blank line at the end. And because we do have a blank line at the end, because when we first wrote this, we have a new line here, a new line here, a new line here, and that new line brings us down to here. And that is what is in that file. And that's what we did. So again, very simple stuff here. You have your file handle.write to print stuff out into the file. And I use the word print a little loosely there. It's technically writing data to the file. But for all intents and purposes, it works very much like the print file we've been using this whole time. We have a file handle for open for read to read things in. And we can read things in the whole file all at once. Boom, just like that. Print it all out. Once the file is there in memory, we haven't learned about things like lists and other things, and that will come actually next week. But once we have data in memory and in a variable somewhere, we can do all kinds of stuff with it. So we'll work with this and we'll talk about other things. For right now, let's look at some more characters and some more things that help us work with files a little better. Looking at a new line, okay, and sometimes we don't want that new line character there. If we want to work with if we're reading in a list of names, for example, and we want to do something and process that name in some way, shape, or form, especially if we're printing it onto the screen, we certainly don't want to print a new line at the end of that thing. We want to strip that new line off when we read it in from the file. And it's important to put it into the file to begin with, otherwise you won't know where the first name and the next name starts and stops. So you need something to separate the names, and for now, we're going to use new lines. Maybe once we start learning about lists and tuples, we'll start using tabs or commas. But for now, we're using the new line. So there's a function called rstrip. It's actually a method called rstrip. Rstrip will actually pull off specific characters. You can actually specify which characters you want to strip off of some line of text. Or by default, if you don't pass it any variables or any parameters, any arguments, it will strip off anything that's white space. So a new line character is white space, tabs, extra spaces at the end, that kind of thing. So let's see what this looks like, this rstrip looks like. So here is a program, and all of these are in your book, mind you, okay? And I hope you're following along with your book in hand or right next to you while we're doing some of these lectures, because it's very, very helpful to kind of follow along here. I did, however, change this one ever so slightly, and you'll see why in a second. So what it does is it starts off, and again, all we have is just one main function here, okay? It starts off with emp file, variable name that stands for employee file, and this will be our file object. It's going to open a file called employees.txt. Well, first of all, do I have in my folder a file called employees.txt? I do, lucky me. That file looks like this. We have a name, an ID number, and a department. Then we have a name, an ID number, and a department. And one more name, one more ID number, and one more department. Okay? So what we're going to do is we're going to open this file. Now here's a new one. We're reading just the first line of the file. So you see we have a variable called name, which we know from our file format there is the first thing we're going to read. If we're reading this one line at a time using our readLine method, we're going to see the first line is always going to be the name. The first line will always be the name, right? Ingrid's name is right here. So we're going to read name, read the first line and into a variable called name. I'm going to print this print statement here, but be that as it may, we have a while loop here, and you see the rest of this is, aside from the close, the rest of this is all in this while loop. And again, we know that we have it's a pre-testing kind of loop. So the first thing that says here, while name is not equal to blank, nothing. So basically, what is the opposite of equal to blank? That means if we have something, okay? If there's actually some text assigned to the variable called name, which we've just primed it right here, while the name is not blank, we are going to go into this loop. We're going to get a variable called IDNum and assign that to the next line. Now, let's open this file again one more time just to see what we're looking at here. Oh yeah, the next line would be IDNum. Then we're going to read the next line and assign that into the variable called dept for department. And that would be this. Then this program is going to strip new lines from the fields. So name equals name.rstrip. Wait a minute. How does a variable holding some text have this method? Well, lots of variables you will find actually have methods attached to them. Most things in Python are objects themselves. So rstrip is not only a function, actually it's not a function that was associated with files, it's associated with variables, specifically string variables. So any string that we have, we can actually use rstrip on. And let me just show you what this looks like just real fast. If I'm going to create a new file here, and I say my name equals Tom Craver, and I just put a whole bunch of spaces at the end of it just for demonstration purposes here. If I say print my name, and let's save this. Sure, that's a fine place to go. And run it. Well, let's do this. Let's say print my name, and then the end character, let's just make it this. So we know right where the end is. That would make a lot of sense, right? Maybe I'll tack on a new line just for good measure. So when I run this, here's our arrow indicating the end of our print statement line, right? Now let's try this. Print, let's do this. We'll say, we're going to follow this pattern here, okay? And we're going to say, my name is now going to be equal to my name.rstrip. And I'm just going to do that. Okay? Save it and run it. Well, it would help if I print that when I'm all done now, wouldn't it? So let's copy this line here. So again, what we're doing, we're making a variable called my name and making it that long with all those spaces at the end. We're printing that out and we're seeing that it ends way over here. Then we're going to use the rstrip function to pull out all those extra blank lines, just so I can show you how rstrip works. And again, we're going to do the same print, exact same print statement, so we know where that ends. You ready? Save it, execute it, and look at that. Here, our separator is here, and after we run the rstrip command, it's literally right next to where the name ends because it's taken off all of this extra white space here. So that, just for demonstration purposes, is what rstrip does. Okay? So as you see now here, we are actually telling it now, I ran it without an argument passed to it, but if you pass it a specific character, it will pull that off. So now this is saying, hey, pull off all of the new lines on name, ID num, and department using this rstrip method. And don't let the dot notation fool you. It's very similar to the math functions or the random functions we talked about last week. Okay, so now what are we doing here? One more time, we're opening this file. We are reading the first line and assigning it to a variable called name. Then we're going to go into this loop because name does not equal nothing. It actually equals something. We're reading the next line, which has our ID number. We're reading the next line after that and assigning it to department, which has our department in there. Then we're stripping off all the new line characters. And then we're going to display what everything looks like. Now, the book just prints this out one line at a time, and you can't really tell that the new line has been stripped off. So what I've done was I put a header before we go into this loop that basically prints off name, ID, and department. Okay? Just as a header. And then we're printing off name, ID num, and department with tabs in between, just like we have it up here. Okay? We're going to print those out. And then the next thing we're going to do at the end of this while loop, in this last of this while loop block, is we're going to read the next line, which after department, so we have name, ID, department, and the next thing will be another name. So we're reading name into the next line. The block ends, so we go back up here, is name not equal to blank? Well, sure, because now we're going to have, the next time through, we're going to have Julia's name. So we're going to do this whole process all over. Now, when we get to the end here, we're going to have Greg and his ID and his department, and when we're all done, we're going to read the last line, which is this blank line of nothingness here. And name will equal nothing, and therefore will end. We'll close the file and be done. That's the hope, at least. So again, let's... probably should have made that bigger before, but there we go. And this is what we're expecting. We're expecting these things separated by tabs with our little header up here for name, ID, and department, right? And if I run this, there you go. Runs quick. And here's our file with our 3 people in it. I'm going to highlight Julia's stuff just to give us some separation here. We have Ingrid, 4587, engineering. We have Julia, 4588, research, and Greg, 4589, in marketing. And this was reading one line at a time, basically reading this, then reading this, then reading this, and again, through this loop, we just keep iterating. And this is where loops become very helpful. And again, a lot of you I chastised a while back for using for loops where we had an iteration, and I said you probably should have used a sentinel to figure out what the end of our input was when we were typing our expenses versus our budget. we don't always know how many we're going to have. So we keep going until we get a certain value. In this case, we want to keep reading a file until there's no file left to read. And that basically is when it's equal to blank, it should leave. So when it's not equal to blank, it should keep going through this loop. And that's the idea behind this. That is the algorithm for reading a file, is keep going until the variable you're reading in, the line you're reading in, is until it's blank, basically. So your test is for if it's not blank, then it would go through here. There's more examples in your book too. Highly recommend you checking them out. We'll talk about them toward the end here as we go through more. Let's talk about append. It's the last part of the last mode, if you will, for using file handles and file objects. Append basically is opening a file for write. Only instead of overwriting the whole thing from beginning to end, it just kind of adds on to the end. It finds where the end of the file is and adds on back to it. So to append data, we use the A for the mode. Okay, it's lowercase a. We had lowercase w. We had lowercase r. This is lowercase a. Again, if the file exists, data is just written at the end of it. Okay, plain and simple. If you use w instead of a, if a file exists, you will delete it and essentially overwrite it. So if you have a long list of records, long list of text, and you open a file with w instead of a, just to add one more, you'll only get one total in your file. But if you use the A for append, you'll keep what you have, and at the end of it, you'll have your new one. Okay? That's how these kind of go through and work. Something else to consider, and there's examples in your book you can go through what append looks like. When you read stuff from a file, it is very similar to reading input from the keyboard. Everything comes in as a string. Furthermore, when you're writing stuff back out to the file, if you are writing numbers, digits to a file, whether it's a float or an int, you must convert it to a string. The write method only works with strings. Weird things happen if you don't. So, we've seen this before. I know a lot of you, much to my dismay, I've told you not to use the string function when you're formatting your numerical output. In this case, when you're writing to a file, you must use the string function to convert whatever your value is, your numeric value, into a string as you write it out. And again, like I said before, I kind of said this backwards, but numbers, when you read numbers in from a file, they come in as strings because we're writing them as strings. So again, like your input statement, just convert them to int or to float before you use them. We talked about using loops. I just showed you the one. Basically, that's the whole idea. That is your algorithm. While whatever line you're reading is not equal to quote, quote. Don't put a space in between those quotes. It is quote, quote. Because you put a space in, then you're looking for the line to equal space. Okay? You want to make sure while line is not equal to quote, quote, which is basically a null string. Nothing in it. Okay? And again, we saw this. I just talked about this and we watch the code run. You open the file handle, you use readLine to prop you whatever your first line might be, and prime your while loop. Did your line return an empty string? No, then process what you just did, read the next lines, and keep going. When it's all said and done, and maybe there's more to your program, maybe there isn't, but don't forget to close the file. Pretty much, if you are reading anything into a file, once you've read the entire contents of that file, regardless of if you're doing more processing or not, close the file. It's just good practice. And in the terms of a network, if you're writing up a program that reads and writes files from a network path, a network that is shared by more than one person, think about Google Drive or think about Office 365 if you ever share documents that way. Okay, any of your cloud documents. They are opening and closing and opening and closing and opening and closing because other people are using them. When you leave the file handle open, it is actually not possible for others to use it. It's kind of a weird process, and it looks really real time, but I assure you it's not. So it's good practice to just close your file immediately upon finishing your reads or your writes. And that way everything is working. You can also use the for loop to do the same thing. while seems to make more sense, but if you know exactly how many lines you have, or if for works in other ways for you, you can certainly use a for statement to do the same thing. So what are records? Processing records. A record is a set of data that describes a particular item. We just had basically an employee record, if you will. And we had a name, we had an ID number, and we had a department, all in the same field. All of those three of those entities together are a record. It's a record of Ingrid's employment with whatever company she's with there. A field is one of those individual pieces of data within the record. So the name field, the ID field, the department field. Each one of those individual pieces is a field. The whole thing together, all three of them, is a record. So one of the things that we use file handles for are processing records. These could be for databases. They could be for just a text file you might have. It could be a data file that you have from Excel. Excel can export to any spreadsheet. Google Docs, for that matter, can export to comma-separated or tab-separated files. They're effectively records, and each field is separated by a tab or a comma, and each record is separated by a new line. And we'll get there when we talk about lists. But again, if you're writing, you write sequential access by writing each one of those fields for all records, one right after the other, and you read the same way. Okay? It's very important when you're working with records to be able to look at your records, search for a specific record, add them, delete them, whole records at a time, right? Modify them. See where you were in the file, and maybe somebody originally typed in Ingrid's ID number incorrectly, so you want to go back and edit that. Okay? But think about anything else you do in life. You want to add a song to your iTunes database. You want to be able to, change it. You want make a playlist. You want to add a song to your playlist. You want to modify the playlist and shuffle the order up a little bit. Maybe you want to take something out of your playlist. Maybe you want to search and see which playlist a particular song is in. Same kind of concept there, right? You have a list of something, a record of all the songs that are in a certain order, and that becomes your file is your playlist in that respect, right? But when you're working with records, these are all the things that you want to do. Databases work this way, and Python is a great language for working with databases. It doesn't matter if you're working on a web interface to a database. Most web pages nowadays are back-ended by a database, and every database is a collection of records that are related to each other, and you have effectively sections of records that kind of tie into each other. Python's good for that. Python's good for parsing long text files of information. Again, something you might export from Excel, okay, or Google Doc. When you're processing records, these are all the things that you want to be able to do with them and make sure your program can do and do well. Let's see. Let's talk about some records, because there's some really great programs that are out there. Let's look at this one here. This is called Add Coffee Record. I'm sure you'll find it in your book. It's somewhere definitively in section 6.2 or 6.3. What does this one do? Well, again, everything's all in this one main function, so let's just look at that here, right? We have main is defined, another equals yes. Oh, look, that's a control variable for our loop. This is priming the loop right now. Many of you did something like this for your budget lab. Coffee file equals open coffee.txt for append. Let's immediately look at this file right now, just so we all get an idea of what we're looking at. Here's coffee.txt. Coffee.txt, I love coffee. Mocha Java, 20, Ethiopian Harar, 10. What could this possibly be doing? Well, let's see. Our loop says, well, another equals yes, capital or lowercase, that's good. Print, enter the following coffee data, description and quantity in pounds. Quantity appears to be an int. So, Then it writes the data. Look at this. Coffee, write, and we had opened this A for a pen, so that's interesting. Description plus new line, quantity converted to a string, plus a new line. Here, folks, for those of you who keep using strings for your print statements in your labs, this is the correct use of a plus when you're writing string data and concatenating strings together. If you're working with integers or floats, you should really be using a comma. That said, coffeefile.write, description and quantity converted to a string with new lines at the end of each one. Do you want to add another one? Y equals yes, or anything else equals no. And it will keep going through this to add more. And then when it's all done, it says data appended to coffee.text. All right, so let's look at this. Let us look at this. So we have two things in our coffee file. We have Mocha Java 20 and Ethiopian Harar 10. We are going to just try to remember that, shall we? Let's run this program. Hey, enter the following coffee data. Let's see. How about Colombian? And let's say we have 35 pounds of that because no one likes plain old Colombian coffee. You got to have something more fun. Do we want to add something else? Yes, let's add something else. How about we add my favorite, Hawaiian Kona? And I like Kona, so we're going to order 90 pounds of that, and that will be extremely expensive at about $50 a pound. No, let's not add anything else. Data appended to coffee.text. I'm so excited. I wish this was real coffee, but let's look at our file. Coffee.text. Hey, look at that. We had Mocha Java, and we had Ethiopian Harar, and now we have Colombian, 35 pounds, like we said, and Kona, 90 pounds. Wouldn't that be a wonderful thing? It'd be a lot of money, but that would be a wonderful thing. And this is your appending of a file. Somewhere I do believe we might even have modify. Add coffee, delete coffee. Oh, hey, let's run delete coffee. We'll see what that one looks like. Okay. Found equals false. What are we doing with this? We are actually going through and searching what we want to find. It's going to open the file. It's going to open one for read. It's going to open a temporary one for write. Interesting. Why would we do that? Let's watch. The description field, we're going to read the first line, what the coffee is, while it's not blank. So we're going to do this until the file is done. Now, what one are we using? We're using the one we're reading from. Coffee file is for reading. I have a feeling that we are going to, since we have one file open for read and one file open for write, I have a feeling that we're going to copy it when we're all done, one to the other. Wow, let's see. So we read the first line. So in this case, we're going to read Mocha Java. Then we're going to read the quantity, which we're casting to a float here by reading the next line. We're going to strip the new line off, and the float will automatically strip the new line off that too. If the description is not what we're searching for, basically what we typed in the first time, then we're going to write it to the file. Okay, so if I say we want to delete Colombian, because again, not my favorite coffee in the world, we are going to search for Colombian. Then we're going to read the first line in, which will be Mocha Java. Then we'll read the quantity in, which will be 20. And then we're going to see, does this first line that we read in equal what we're searching for, the Colombian? If it does not equal it, we are going to write everything we just read in to the temp file. If it is, then we'll say, okay, we found it, true. And then we're going to go and read the next line for coffee, which will be down to Ethiopian Harar. When we're all done, we're going to close those two files. Now, one was for reading, one was for writing. So basically what we're going to do is we're going to write everything except for the one we found. When it's done, it's going to close those files, and then it looks like we're going to remove the coffee file and rename the temp file back to coffee. So that's kind of a cheating way of doing it, but it's a neat little slick way of doing it. If this found flag was set to true, because it's possible we might not find one. I might say decaf, which isn't in this list. But if we found it, we'll say, hey, the file's been updated. And if not, we'll say, hey, we didn't find it. No big deal. So let's try this. Let's run this the first time, and I'll say Colombian, and we'll remove Colombian from this list. Okay? What coffee do we want to eat? Colombian. That was quick. Why do I think I don't believe it? But we'll find it. Coffee.text. Look at that. It's gone. Again, probably should have did this before so you guys can see it a little easier. My bad. Interesting. Let's run it again one more time. Over here. What coffee do I want to delete? I want to delete decaf, which doesn't exist, we know. That was not found. And our file is unchanged. Let's actually reopen it here just to make sure. File is not changed. And that's kind of the whole idea when you're processing records, right? You want to be able to do all these different things. Here's the modify coffee record. And again, one more time. We'll look at this. We have 90, let's see, 20, 10, and 90 for the Kona. And what does this do? Again, it searches for what you're looking for. It goes through a loop with a temp file and a real file, and it looks like when it's all done, it's going to remove these things and recopy them over. And it's going to write the new amount. So let's say we run a coffee shop, and let's say you run the coffee shop, and this is your program, and I came in knowing that you have 90 pounds of Kona, and I have some extra money. It's expensive, so maybe I can only buy 10 pounds of it because it is $50 a pound. So I'm going to say we're going to look for Kona, and instead of 90 pounds, after I buy, let's say I buy 50 pounds of it from you, then you're going to have 40 left, right? So that's the new quantity. The file has been updated. That quickly it iterated through everything, and if I open this file now, Kona is now 40 instead of 90 like it was. And when we process records, we should be able to do all these different things. That is, in fact, exactly what we're talking about. Being able to add records, delete records, find them all and read them all in and display them, search for a certain one, and then do something with that, whether that's modifying it or deleting it. All of these examples are in your book. I really highly encourage you to go through, check them out, practice with them, play with them, and make sure you can get them to work right. That's all I'm going to talk about as far as file handles this week, but there's one more thing that we need to cover, especially when you're working with file handles, although exceptions are not specific to file handles. Exceptions are basically error checking. I'm sure some of you have seen it when you've run a program and had not so much a syntax error because it doesn't even run when you get that, but you have a runtime error and you go through and maybe there was a value that was wrong or some such thing, and I've put comments on your labs and highlighted it in red text just like it prints out in the Python interpreter and say, hey, you had this exception that got flown, here's what happened. So what is an exception? It's an error that occurs while the program is running. And generally speaking, it almost always causes your program to halt, and Python will write something out in big red letters. There's something called a traceback, which is the error message that actually tells you what caused the problem to happen. So let's see here. Where's my files? Probably should go to something a little simpler, but actually here. You know what? Let's do this because I know this one actually will work. And this is pretty simple. Here's a program that will basically divide two numbers together, right? It asks you for input number, or, gives you number 1 and number 2. So if I say 10 and 2, 10 divided by 2 is 5. And we know that it turns into a float, right? When we divide things. If I run this program again, and I do something like 10 and x, I get a traceback. Again, it's an error message that gives you information, including what line threw the exception. Line 13 in my code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, main, that kind of sucks. Oh, but line 6 division.py. 1, 2, 3, 4, 5, 6. Oh, number 2 is supposed to be an int. You can't convert an x into an int. That throws an error. And that's what we're telling us. Invalid literal for int with base 10, because integers are base 2, or base 10 rather, x. Doesn't happen that way. Let's try something else. Enter a number. 10. What happens when you divide a number by 0? You actually get an error because you cannot divide something by 0. It's mathematically impossible. At least not in real numbers. And that threw an exception as well. And again, it tells us line 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, right here, when we're doing the division statement. So if you haven't figured out what all this red text is, this is what it is. This is basically telling you that an error happened. It tells you what line number it's on, and the message that it gives you is called the traceback. It literally even says that, traceback. That's what it's called. So those are exceptions. What do we do about them? A lot of things can throw an exception, right? And we've all seen that when we're trying to do something and we get that red and we say, okay, we didn't do something right. Now, when you turn in your lab assignments with that red and you know it doesn't work, that kind of gets under my skin a little bit. And you should be doing better for yourself that way. Now you know what these exceptions are and how they're handled and what you should do about them. How do you get around them, though? Because what's more important, and why we're talking about it in this file handle lesson, is because sometimes you may go to open a file and the file doesn't exist. At least opening it for read and it doesn't exist, you're going to have a bunch of errors sitting all over the place. Or somebody already has that file handle open and is writing to it currently while you're trying to read it and it isn't complete and it can't read it in. It's going to throw an error on you. Network is down. You're going to throw an error. So you have to do something so your program doesn't crash. If you are doing something like a database and people are relying on your reliability, people are relying on you for having working software that will work with their data so they don't have to worry about losing it, then you want to be able to fix these errors. So what we effectively have is something called an exception handler, and it works with two statements, try and accept. And the try and accept pair go together to basically try to handle the error when they happen. So the try suite is essentially a block of code that starts with try and a colon that is code that you think might raise an issue. So in the case of this division statement here, we know that casting to an int and dividing this out could potentially, if somebody does something wrong, cast an error. So these might go into a try block. Okay, we'll see that shortly. The handler is basically all the statements that are done in what's called the accept block. Now, the try block is not actually called a try block, it's called a try suite. Likely because they're already blocks in themselves from loops or other things. The handler are basically, it's an accept line with some kind of exception name, and then a block of code that goes underneath that too. So it looks something like this. You have try, colon, a bunch of statements that, are part of your program, and then you have the accept block, and then an exception name perhaps, that tells the program what to do if it finds a particular error. Okay? Basically, that's what it's trying to do. If it tried to do something and it got an error, caught an exception is what the phrase is there, then based on what the exception is, based on the traceback, the exception type, then here, do these statements instead. And part of that might just be, hey, try it again. Or wait till this happens and then try it again. And again, for those of you who've seen this red output in the Python interpreter, that's what we're talking about. So again, if a statement inside the try suite raises an exception, then what happens is everything in the accept clause that is based on those particular exceptions that came up will be executed. If it's something else that you didn't look for, then the program will essentially halt. And then again, if everybody does what they're supposed to do and they don't type any incorrect input, then that whole exception block is skipped. So it's kind of like an if-else loop, and I don't want to say that terribly much because there's an else statement coming up for this too. But if something happens, well, In the try block, these are always going to be executed. In the exception block, it will only get executed if an error happens. So, try suite always happens. Except block only if an exception is thrown, only if an error actually occurs. You can write an except clause for very explicit types of errors, like a value error. Now, what did we throw back here? We threw a value error and a zero division error. And so that would be the exception that you use, actually. If we talk about, where did we go here? The exception name. The exception name is value error or zero division error. And if you are looking for the wrong one, then this will not get executed. Okay? You can look for multiple types of exceptions. That is fine. And if you don't list a very specific one, it'll just say, hey, if any error happens, just do this instead. Okay? And that should always be the last thing you do. So look for this one, look for this one, look for this one, and then if all else fails, look for this one kind of thing. And I hesitate on saying it that way because there are other statements that go with this too. But if we're looking for a value error, for example, we say accept value error as error, and then you can do something. Like go to a print function and say, hey, print, hey dummy, you typed in the wrong value. I'm looking for this kind of value. And then you can tell it to try it again. Okay? There is an else clause. So we have try, we have accept, and we have else. And it's very much like an if-else statement. And again, else is called an else suite, not an else block. And it is the block of statements that are after the try, but only if no exceptions were raised. So again, we have a try block, we have try and some statements, accept and some statements. The try always goes. The accept only goes if there's exceptions. The else goes if no exceptions were raised. So if you know something has the potential to go wrong, you definitely want to use a try and accept. The try things are, here's what we're going to do. There's potential for error. If something goes wrong, do this. Else, do this. So again, the else suite will only take effect if and only if there are no exceptions raised, if there are no errors that are thrown. So try, always run. Accept, only run if there's errors. Else, only run if there's not errors. And finally, yes, there's actually a finally clause. And finally comes after the else. In the indenting world, it's aligned with try and accept. So you have the try block, try suite, the accept block, the else suite, and now we have the finally suite. And again, it's just another block of statements that are always executed no matter what happens. It's always executed after the try, and if any exceptions happen, it's executed after that. And again, whether an exception occurs or not, this will run. So if you have no exceptions, you'll do a try block, you'll do an else block, and you'll do the finally block. If you do have errors that happen, you'll do the try, you'll do the accept, and you'll do the finally. Okay? And basically, what you do with finally is if there was a lot of things that kind of blew up, finally is kind of your cleanup. It's the garbage crew that comes by that says, okay, we're going to fix this, so we can get on with life and actually end this program properly. Okay? What happens if you don't use try and accept? Well, I mean, many of you have seen this already. You get these fantastic lines of red text that tell you what's going wrong. Now you know what they all mean. You hopefully do. If not, rewind me and listen again. But if they don't go handled, then basically your program is going to crash if something goes wrong. Almost every time, if you don't accept the right thing, or if you accept something that's not in a try suite, or if something happens that's not in a try suite, the program's going to stop. You're going to get that ugly red text, and the user's going to probably be a little upset that things ran wrong. And your professor's probably going to think that you don't care that you submitted a program that actually has a runtime error and you didn't bother trying to fix it. And he'll probably take points off for you. So yes, there are labs next week that will reinforce all this stuff. The most important thing is your quiz at the end of this week, that's due at the end of this week, is on Chapter 5 and this chapter. So my advice to you all is to practice, okay? We talked about a lot. We talked about file handles, how to open, for read, for write, for appending. Know those three modes. Know how to use them. There's some great examples here. The employee records one and the coffee records one are all out there. Section 6.3 is the one that works with records. Okay? It's definitely a little more practical. Those coffee records are really practical. The employee records are really practical. But play with the ones in section 6.1 and 6.2 as well, the simple ones that just open and print it off the the employee list or print it off. I mean, other things. There's the philosopher names. There's a friends list as well. Go through and just play with those. Try to figure out how they work. Then practice your try and accept. There's great examples. Sales report 1, 2, and 3.py are all out there. Sales report 4.py also brings in the else clause to play with as well. The book examples are a little lacking. All they really do is print an error. They actually literally print the variable called ERR, which is the error message that gets thrown, which is not much different, except that it's not in red text for you and doesn't crash. So my suggestion to you is play around with that. Figure out what you can do with the accept statements and how to get them to go back over and try again then. Practice makes perfect. I wish you all a lot of luck. Again, the Q&A forum is out there for this week. Throw some questions out there, or if you find something weird that happens as you're practicing with some of these files, please share it. Let everybody else learn from your playing around or your mistakes, either way. If there's certain questions, I'll answer them there. As you all know, I will answer questions via email and happy to take a virtual Zoom call anytime except for Sunday this week. So you've got a few more days left in the week. Make sure you take advantage of it. Practice, read up on chapter 5 and 6. Both your lab and the quiz are due at 11:59 p.m. on Sunday. Hope you all have a great week, and we'll see you next week.